Hello everyone, Robert Saunders here again from Dell, and I wanted to talk today. There's been a lot of asks to understand how I can set up native replication between two different Apex block clusters in Azure. So we're going to show all of the details today. Now, we'll be able to show crash consistent copies. We'll be able to repurpose snapshots. And of course, we can do all of this with the UI, the CLI, or REST APIs. Today, I'm going to show a lot through the UI just so everybody understands how everything pieces together. This is going to be a really cool demo. So first and foremost, we do need to have some ports open. Now you'll see here in my demo where I actually open up the VNets on both sides. I have a region in the east, I have a region in the west with two different clusters, but these are the ports that I need open for the SDR and the MDMs to communicate. And I have to also upfront talk about some documents here that we have from Dell. If you go to InfoHub, delltechnologies.com, you can search for these, or you can copy the URLs. The one down there, the PowerFlex replication one, that's a great one. And of course, our Terraform module is also below. That's how I actually deployed. There's another video on that if you'd like to take a look. So let's take a look first here at the topology that I deployed. I have, again, two systems, one deployed into an east region. It's using the 10.2 address space. And I have another system deployed to the west region, and it's going to use the 172.16 address space. You're going to see me use these address spaces and go back and forth between them, between different tools here in the demo. So remember, 10.2 is the east and 172.16 is the west. Again, we have the metadata synchronization. We have a replication consistency group there in the middle. We're going to peel all this apart here in a second. And I stitched everything together with VNet peering in Azure between these two regions. So let's go into it here. So right out of the gate, here is the remote protection overview, the RCG, or replication consistency group. This is kind of the landing page here. It's under protection overview. So let's drill into this. You can see a few things on the right. I've got the RPO. I have a workload that's not running just yet. And then at the bottom there, we see the west cluster and the east as a source. So here are the 5 SDRs. If I wanted to first load the SDRs, I could do this option using the CSV to populate the IP addresses. I've already done it, but I'm kind of backing into it and showing you exactly what lays out here. So this is one way to install it. There are other ways. You can go to the settings, getting started here, and then you see this deploy with installation file. And I already have the packages uploaded here. You can see all the packages that we need for a successful PowerFlex install, including the SDR. And then I'm going to browse to the CSV location. I already have it loaded up to the server here. And I'll upload it, check the terms. I can leave everything blank here with the options, and I can click next. Now I get to scroll through everything. This is the same CSV that just got loaded in that we just took a look at. There's the SDSs, and then the SDRs that I'm going to populate with that package. Now, if I click finish here, it will go off and do the work. There's all the IP addresses. This is just presenting what I had in the CSV back to me, making sure everything is correct. This will start the SDR install. I've already done it, so I just wanted to show that right out of the gate. Here is the Apex block infrastructure as code, one of the regions, the east region, that I deployed actually with Terraform to build out the entire cluster. That's another video. If you want to watch it, you absolutely can. So east and west VNets, as I mentioned earlier, they're peered. There's the peer, and then the remote virtual network name is the opposite, west VNet. So I peered these all together. All of the ports are opened up by default when you deploy with Terraform. So that's all behind the scenes there. That's already been done and opened up. So really all I had to do was peer the two networks, and then I allow sharing and communication between these two networks. So I'm actually going to work on one jump host in the east region, and I'm going to be able to see PowerFlex Manager in the east and in the west because I've allowed this traffic to work. So again, there's the peering, and of course, the resources. So first one, demo and mount, or do a test failover, and mount the snapshot, and then do some testing on the other side. So we're going to browse to the RCG. In this case, I'm using a SQL Server workload. And inside this RCG, I have SQL data and SQL logs. So 2 volumes that are attached to my SQL Server, also in this resource group. And I have another SQL Server on the other side that I'm going to mount these volumes to once I do the test failover. So let's do that. And again, I'm trying to simulate here what happens, and we do have clients ask for this, what happens if a region fails? If communication, for whatever reason, goes down, they want to be able to stand up their SQL Server workload in another region and keep going. That's exactly why we have this. So I'm going to start up a HammerDB workload. I love using the HammerDB CLI. So I'll just copy and paste here some notes and I'll kick that off. So this will start off just a workload. And I'm only doing this for functional, not performance-based. I just want to have some work going on my SQL Server. This is the easiest way for me just to start it up and let it work. So here's the presentation metrics. You can see as soon as I started it, I have my RPO set to 15 seconds, which is the minimum. Down here in the bottom, the source system, the blue one, is east, and that points to the west cluster. That's the remote system. So these metrics will kind of go up and down as replication is going. That's perfectly fine. I can also monitor the RPO by RCG. That's over there on the right. That lag will kind of go up and down a little bit. It never really gets over 15 seconds, which is great. I can adjust everything. If I want to, maybe I want to adjust my RPO or do some other actions against the RCG, I can do that there. But what we're going to do here is start test failover, and we're going to failover east to west for a test. So here I am. I'm going to go ahead and start the target failover. So start test failover. Now the RCG continues to be journaled and replication continues during this test. You'll see the state here goes to failover. Now I open PowerFlex Manager. It looks the same because it is, but I open it on another, on the 172 on the west side. So now I'm going to go look at it from the view of the west. My source system is the east. I'm in the state of failover test. So now I'll go to the SQL Server that's over on the west. I have a SQL in east and I have a SQL in west. This one you can see here, the disks, because I just went to it without refreshing, they're not initialized. That's perfectly fine. So all I'm going to do is rescan. Boom, they're online. So now I can actually, from a DBA perspective, I can jump up to SSMS and I can attach this database and I can do some write tests. So let's do that. No databases are attached in the 172. Remember, that's the west side. So I have all my notes scripted there, all good to know. And I'll connect with SSMS to the west side. And all I'm going to do is run a SQL attach, super easy. Attach the database, which is attaching what? The MDF and the LDF. That attaches, all done. I'll refresh Object Explorer. There it is. So now let's run an update statement, which is going to simulate a write. I'll call it Saunders Snap. So I'll run the update and I'll select statement before, select statement after. Let's take a look at the results. It was Saunders test before and then Saunders snap after. So I can confirm that I can do writes when I'm doing a test failover on the DR side for my SQL Server use case in this example. That's pretty cool and that's really powerful, especially for smoke testing, DR testing. You want to make sure everything's working. Now, all I want to do to get back to our desired state is detach that DB and stop the test failover. So I'm simply going to run alter database sp detach DB, done. I can refresh Object Explorer, it'll be gone. Now I'm just going to stop the test failover so replication can continue. I'll approve it. Test failover complete. So that's the first option you can do using replication. Let's rescan it and we'll see that these disks are going to be back offline on the west side. So now we'll go back to the east and let's do demo 2 here. Now we're actually going to conduct a DR failover, uncontrolled region failure, I'm calling this. And all I'm going to do is I have my workload running there with HammerDB. That's great. I'm just going to go in and do a failover from a PowerFlex perspective, and I'm going to start running the workload in the DR side. And I'm going to run over there for a while. So the SQL Server workload again is working here on the east, humming away. The RCG is healthy. I can see there it's green at a 15-second RPO. I'll go into the RCGs. Again, I have 2 there, one for backup and one for SQL data and log. The SQL data and log is the one I'm going to actually fail over. I see activity monitor, check the workload. There is work going on. Let's actually go in here and take a look at some counts. So here we are. There's the connections for HammerDB. If you're familiar with HammerDB and the tables it creates, we see some logging and some orders going through the database. It's exactly what I want. I know work's being done. And then I have about 40 rough and tough TPCC app connections from HammerDB to SQL Server. Perfect. So I have work going on. It's exactly what I wanted. So now my scenario is the East region just goes offline, an uncontrolled failover. How am I going to mimic that? I'm just going to do a failover with PowerFlex Manager. So we'll go to the RCG and we'll go to more actions, failover. Now this will simulate, as I mentioned, that the connections are lost. So as soon as I click failover here, you're going to see HammerDB get pretty grouchy and drop all its connections. It's exactly what I want to happen. So I'll click proceed and there it goes. HammerDB got pretty mad. So it's in a switchover state right now. The workload is no longer connected. I'll stop that from a HammerDB perspective. And now what we do here, which is key, first we fail over, now we reverse. What does that mean? The West cluster is now going to be the source for our replication. So I'll reverse the replication. And now you'll see there that flips. The source system now says West, and the target system is the East, but it may be offline for a while. That's fine. We'll journal the replication until we can push it back forward again, or we'll have to reseed depending how long we've had our outage. That's perfectly fine. So now this is key. I'll go to the SQL Server again over on the West. Remember this from when we did our snapshot. We need to rescan the disks to make sure they're online. There they go. We're online on the West SQL Server. Let's make sure we got the data, the TPCC MDF and the LDF is there. Perfect. It's exactly what I wanted. Now, just like during the failover test, we're going to attach the same pattern. So really, after you practice this a few times from a DR perspective, you're good to go. Connect to the West. That's the 172. So I'll connect to it real quick, and what am I going to do? Just like the failover, like I said, you're simply going to attach the database. I'll refresh. SQL Server does not know about the TPCC, but until I do this. So create database for attach, boom, done. Refresh the tree. There it is. Perfect. Now I have SQL Server in the West ready to accept some work. So I have HammerDB also running on a jump host on the West. Let's just start up some work. Again, exact same, except it's connecting to SQL Server on the West. So I'll kick this off just to have a workload running while we're talking through some more steps here while we're failed over into this DR state. So we know that's done. We can absolutely connect to West, and let's run those same counts. So I'll connect to the 172 again. And now I can simply run the counts. There it is. I see it's connected to 172 with the HammerDB user. I see orders. If I refresh this a few times, I'll see the orders line, the order line incrementing. And since I just started it, my initial connections start with 20, then go to 40. I see 20 plus or minus connections to the TPCC database. Work is being generated now on the west side. Super easy. Now let's actually update some rows. Now I want to do this because I want to open this table, this customer table, back when I get to the east as my primary, and we'll see that these records made it all the way back. So Saunders, it was the obfuscated data there, and then Saunders test rep, I updated the last name to. So remember that, we'll take a look at that once we fail back to the primary side. So when east is back online, now we can fail back. So I have to do changing connections here. Back to the 10.2, which is east. I'll connect in, and now I want to make sure before I fail back that SQL Server does not know about a database in its purview. So I'm going to drop the database, the TPCC, on the old primary site, the east side. I'll refresh Object Explorer. It's gone. That's exactly what I want. Now, what I should do is gracefully shut down the workload as I have a controlled failover this time from DR back to my original production side, which is the east region. So I'll stop the workload I had running in the west. Simply just break out of this and terminate that job. So let's confirm the connections are gone from the 172 SQL Server, the west side. No more connections. No more connections are there, and then the count at the bottom is just the only one that I'm connected to here. So that's perfect. So now I'm very confident that I can fail back, no more writes. I simply detach the database like we did before. I'll refresh it. And why am I doing this? I'm doing this actually so SQL Server does not know about it. I go back to east, but then I'm in a clean state. If I ever had to fail over again, everything's already taken care of. So if you follow these steps like this, over to DR and then back, everything is super easy to do as long as you follow these simple steps. And it can all be scripted and automated, absolutely. So now I'm detached from the west, and I can simply go back into PowerFlex Manager, find that RCG, and do what? I need to fail over. And once I fail over, I reverse it. So I'll apply my failover, click Proceed, and then select the RCG, as I mentioned, and click Reverse. A little bit of confirmation. Click Apply, and we'll see this flip back to the target system, west cluster. The source is that system and that identifier. That's the east. I see I have a little bit of RPO violation, sure, just for a couple seconds because replication is catching up. So I'll let this stay here, and then just a few seconds, it all goes green. So all my transactions went from the west back to the east, and now we're all in sync. Now, the East SQL disks are back online. That's great. I'm going to connect or change connections first back to the 10 dot. So now what we're going to do, we're going to attach the database just like we did before back to the east. We know it wasn't there because we dropped it earlier. So I simply attach. There we go. Now my SQL Server database is attached back to the East SQL Server. Refresh Object Explorer. There it is. We're ready for a workload. Perfect. I can kick off the workload with HammerDB again. Now this is going back to the east. Let's confirm that. Back to the desired state. Connections returned. We just kicked it off, so we have 20 plus or minus users, and we're getting rows inserted. Now, let's take a look at that select statement. It should say Saunders test rep or something like that. There it is. Saunders test rep. Perfect. So the rows that I wrote on when we were over in DR did make it back over here to the primary state. That's perfect. That's exactly what I wanted. Look at my RCG, back over to the main page for PowerFlex Manager. Now the final demo here is a little bit about snapshots. The cool thing here is we can make snaps of snaps, and we can also repurpose those. We can delete a parent of a snap. This is pretty powerful. Now I'm going to do this from a view of making a volume that I have attached actually to this jump host, and I'm going to present the additional snaps to this jump host. So I have a volume there. Disk 2 is called Rob Jump Volume 1. There it is. No snaps currently exist. So I'm going to create one. I'll give it a name. There is a limit here on naming. I'll uncheck read only. So snap 1 is created. There it is under snapshots. Let's create a snap of a snap. I'll call it snap 2. Boom. There it is. Let's create one more. Let's call it snap 3. There we are. So now I have 3 different snaps that are created from each other from an existing volume that we started with. Now I'm going to map all these snaps to this jump host. So you'll see 3 volumes. There they are. Everything just landed. And I bring them all online. There we go. All 3 volumes. Now, why would I do this? Maybe I need some version testing. Maybe I've made some small updates to some data or some app code, and I want to test different versions. I can easily do this with snapshotting. It's extremely powerful. All the snapshots are contained within the cluster, and it's simply pointers. So we can review the V tree here. We can see how that snap was built from that existing volume. Back to the snapshots. Now, I mentioned this earlier, you can unmap and delete any of the snaps. I'm going to do the one here in the middle, the second snap, which is the parent of the third snap. That's pretty cool. So I'll unmap it, and then I'll just delete it. That's awesome. Really cool demos. Thanks for watching Apex Block PowerFlex native replication in Azure. Thanks very much.